Hello, my name is Yiannis. I am part of a team at Protocol Labs. I'm a research scientist, and I'm going to present work that we've been doing with people, of course, from Protocol Labs, but also from a wonderful wider community that we have working with us, much of whom are around here as well, and you can meet them later. So I'm going to talk about what we're building, which is called the IPFS Observatory. And this is what kind of motivates us, the fact that you can't improve if you don't measure stuff, and then you should measure what you think you have improved in a protocol. So unless you have the methodologies and all the tool chain to go and find that you have successfully deployed an improvement to your protocol, you can't be sure that it's actually improving things. So we see measuring network protocols not as an end in itself, but rather as a means to an end, which is to identify bottlenecks and problems that you have with your protocols, quantify how much improvement can be done with what you're doing, with the protocol that you're working on, and design, of course, protocol optimizations. This is a huge space. I'm just going to cover our first order priorities here. And then I'm going to give examples of what we've done, what we're looking to do, and how we can work all together. So the high-level workflow is obviously pretty simple. We measure stuff, then we identify problems, and then we fix problems, right? Not rocket science. So I'm going to start with a couple of examples to try and convince you that measuring and then optimizing things is an important component of anyone that is building protocols. So we have what we call optimistic provide, and these came out of measuring how long does it take, how much time does it take if we want to publish something on the IPFS network, right? So we have a web page, a document, whatever, and we want to publish it to the network and make it available for our friends and everyone to find. So this process, as we see here, takes tens of seconds and sometimes like goes to more than 100 seconds, right? Which is pretty long for internet standards nowadays, right? So what we have seen is that when you try to actually get into the details and see why does it take so long, you realize that it actually can be completed in less than 1 second. Why this happens? Because when we try to publish something using on IPFS, using libp2p, of course, we need to find the right people to go and store something that is called a provider record, and these people then, these peers, are going to be responsible for letting others know, responding to requests to say who has got this content, you know, point them to the right direction. So this process takes time and takes all these tens of seconds. What we figured out through measurements is that those people that we eventually choose, we know them and we find them in the process, like in the first 1 second of the whole procedure. So there is a big opportunity of like an order of magnitude improvement that we have figured out and we're currently working on. So there is a talk on opportunistic provide by Dennis tomorrow, so you're going to learn more about what is so optimistic about it. Now, the second thing, the second opportunity is that we figured out through measurements is the following. We wanted to find out what does content routing look like in IPFS, especially using the DHT that Max went into some detail. So we wanted to break down things in steps and figure out how long does it take, what's the latency to go through each of the steps, right? What we wanted to do, of course, is a controlled experiment. So we deployed IPFS nodes in several different geographic locations across the globe. We then created content like CIDs and like specific content that only basically our nodes knew. And we started requesting that from all around the globe. And we monitored how long did each one of them take. So great, we have a controlled experiment. As some of you might be familiar with the process, what happens is that IPFS first uses bit swap to to ask all of the immediate peers, like as a peer in a peer-to-peer network, you're directly connected with a number of peers, and you ask them in case they have the content you're interested in. Then you wait for some time, then if that doesn't play out, then you go to the DHT and you ask there, you go around the ring and you try to find the right person. And eventually you get the content. So in our experiment, what we figured out is we broke these down. So here you can see the overall retrieval duration on that figure down there. The middle figure is how long it takes to do the DHT walk and find out what is the peer ID and who has got the content that you're looking for. And then finally, fetch the content again using Bitswap. So if you notice there, first of all, we see that the DHT, the liée P2P DHT nowadays is performing pretty well. You'll see that from several different locations, depending a little bit on the location, you can do the DHT lookup in less than 1 second, right? Which is pretty good performance for a peer-to-peer network compared to peer-to-peer networks in the past, IPFS itself in the past, and so on. So that's pretty good news. The other thing we see, though, is that if we compare, like these two figures are pretty much like similar. If you see down here, you notice that everything starts a second later in the overall duration. So this is because the Bitswap delay, the initial step of asking the immediate peers takes this 1 second. And that can be very useful for some applications or some nodes in the network, but not for everyone. If immediately this kind of begs the question of, is it worth waiting this 1 whole second if the discovery rate of Bitswap is not high enough? So if you're continuously asking your peers, but the number of times that you get a response back is 1 out of 1,000, then perhaps you're wasting 1 second waiting, and the chances of finding it are very small. So what we want to, if our hypothesis is correct, which says that it's not going to be very successful for very many cases, then we could apply very simple protocol optimizations that would say, let's not wait 1 second before we start the DHT lookup. Let's do these two things in parallel, or let's shorten this 1 second, because basically you're adding 1 whole second, like 100% of the latency to looking up content on the network, which is a lot. 100% is 100%. So that's two kind of low-hanging fruit and opportunities that we have found out recently. And now we're opening up many of those to grants for the community to come and work with us. We have, if you go to the decentralized grant management platform, dgm.xyz, you're going to find many projects, and we're starting to put in projects there for IPFS and liée P2P ecosystems. So this one is one of them. We have a methodology. We want to go find out the success rate of Bitswap and come up with what optimization is going to be best for every peer, every node, and every application in the network. So that's one way of getting involved and working with us. Now, more generally, these, as I said, are two of the immediate studies that we're working on, but we've got more. We did a very big measurement campaign using the famous by now Nebula crawler. That I don't think is part of the program here, but the author of this, Dennis, is around here. So come and talk to me or to him, basically to him, ideally. If you want to find out more, of course, it's open source, and we've been collecting data since last summer. And we recently narrowed down and did an analysis on some part of the data. So, and there are several metrics. I'm just going to mention some of them. We've got a technical report I'm going to point you to, and several other places where you can see what other things we're finding out. So you can do several things. You can see the agent version uptake. So there is a new release. How quickly do users update their nodes in order to get advantage of whatever new feature you just released? So it's very important to have a look at that. You can see the peer churn, and here is a quick quiz. So there has been lots of discussion around it. So who has the answer to this question? 50% of peers leave the IPFS network after X hours. Anyone takes a guess? No, no one. Okay. Sorry? 12 hours is mega wrong. Yeah. So, yeah, it's roughly 1 hour. According to this latest result, which must be from this week or something, we see that it's 2 hours. So there have been studies far back, like 20 years ago, that talked about roughly these figures, 1 or 2 hours, and it's still the same. It's pretty surprising, but things are still the same. But you can find out other things. You can find out churn rate, for example, by agent version. So we see here that that probably does not, is not very clear, but this is the 0.9 release of IPFS, is much more stable than some of the most recent ones. So you can figure out, if there is some bug in the release or if some application is causing things and things are not looking very good. You can also see, what parts, which nodes or agent versions are churning more. So here we figured out just yesterday, actually, that the Hydra nodes are, something is wrong with them. The previous times I'll show some weekly reports that we produce. The Hydra boosters, which is this orange brown line here, they used to be something like this here because they're very stable. They're maintained actively and so on. So you can identify problems with the infrastructure. So it's very, very important to kind of go and see how, dig deep into the protocol specifics in order to see what's going on in the network. Another one. Dependency on cloud infrastructure. So what do you think is the percentage of IPFS nodes that is deployed on big cloud infrastructure? So say AWS, DigitalOcean, Azure, and all that. 5%. 80. Okay, wow, okay. Strong opinions. No, nothing like that. So it's less than 2%. It's almost 1%, and that's also very surprising. Yeah, a pinch of salt, but we've done this experiment again and again because we were also surprised. Quick disclaimer that this is about big cloud infrastructure that the big cloud providers are making their IP ranges public and available. So there are nodes that run on smaller cloud infrastructures that we just don't know their IP addresses. But yeah, a very encouraging result, right? As a decentralized network, you wouldn't want 80% of the network running on AWS. Probably, I don't know, it would be a little bit awkward, but it's not like that, right? So good news. IPFS nodes are deployed on 2,700 plus ASs, so pretty distributed, like quite a lot of ISPs. Of course, not covering like the tens of thousands of ISPs, but yeah, some of them are anyway pretty small or out of context. But there is some concentration there as well. So the top 10 ASs contain 65% of the IP addresses that we have found. So there is some concentration there, but still this does not mean that, for example, in terms of resilience of the network, that would present any problem. So yeah, maybe let's be brave. I'll show you the, okay. Yeah, so we're producing these reports every day. They are under an ugly link, but they have some very interesting results. If I can scroll up, you can see the percentage of nodes are online, offline, constantly offline, or dangling from the point of view of coming in and out of the network. What percentage of the network is stably online? What number of nodes or percentage of nodes we've seen as one-off and so on. So there is some like the dialable peers by age, and there is churn rates. There is also inter-arrival times, which is another very interesting metric. You know, peers churn and go out of the network, but also they come back, right? They don't leave and the network disappears. It's just that someone leaves, and after an hour or 2 or 5, they just come back online. So that's very interesting to look at as well. And then there are several graphs there produced automatically for different versions, different implementations, and so on. So very interesting. You can I can share the link, and we plan to put it in a more visible place. So let's go back to that. Okay, it worked. So yeah, we also produced a 12-page technical report that I'm more than happy to share with you. There is a lot covered there on the internals of how the protocol works, our measurement methodologies, and all the results that we found. This is a set of great individuals we worked with. So much of what I've talked about is not obviously my work, it's teamwork with all these communities. So thank you very much, everyone. And some callouts. So much of what we're doing is obviously very useful for liées P2P and IPFS, but it's important to stress that it's not only for that. So many, like, of course, as people here know, if we're building on top, if a company or individual is building an application on top of liées P2P, we need to be able to provide some glimpse of what things would look like when you go and deploy your application and like build your business or whatever. So it's very important to have these tools to be able and support the community and the developer community around that. It's also very important to know that these measurement methodologies are not necessarily targeted only for liées P2P. Of course, that's our first order priority here, and that's what we're doing, but you can like measure other systems from the WebP ecosystem, from peer-to-peer networks and so on. So there is lots of value there, and it's very good to come and work together and make them better than we can do on our own. So here are some projects. We have 3 ongoing projects. Again, not hole punching. Max introduced that, and there's going to be a talk tomorrow. We are working to see what's the success rate, because it works, it has been tested and so on, but it has not been tested in the wild to see what is the success rate that all of us are going to see when using it. So we're working on that. Gossip sub performance, this is another very important protocol of the liées P2P library that we need to have a very good idea of how it performs. It's a pub sub protocol. We publish a message. How long does it take to reach the entirety of the network? We have a rough idea, but we should be much more definite and confident about it. And then there are other projects such as the DHT routing table health and several others. Now, ways to get involved is we have all this effort to measure the Web3 stack and IPFS and liées P2P. It's called Probe Lab. It's, that's how we call it. So there is a link in those slides which I can share with everyone. It's a Notion page where you can find our discussions, context around each one of the mini projects that we're taking on. And we're also starting putting grants in the DGM platform. So currently there are 2 already open, but we plan to put like more than 10 in the next couple of weeks. And then there are going to be others coming in batches and so on. So get interested, get involved. Come and let's work together to find better methodologies for all of that. And a final note, we are organizing a workshop alongside an academic conference in July. That is going to be another very good venue to come and discuss your work, see what other things are going to be presented. The program is almost out. You can find it using that link that you cannot see there, but I can point you to it. There are going to be liées P2P folks, but not only. There are going to be 10 papers, 3 tutorials, 2 demos, several invited talks. So we need to figure out a way to fit them all in a day, but it's going to happen. So book your tickets and come along. And yeah, that's it. Thank you. Let's have a chat, and happy to be contacted. Thanks.
Thank you so much, Yiannis. We have time for questions. And I know there is one or two. Come on, guys.
Hi, this super interesting talk. Thank you. So I saw that when you were running the metrics for the retrieval at the very beginning, for the latencies, that you had created kind of like a staging environment.
Yep.
Have you thought about trying to run that experiment, but with like real data, or is there like a technical struggle there?
Yes and no. So real data, you mean data that has been requested
like
from the
actual
IPFS
infrastructure? Yeah.
It is, well, yeah, it is actual infrastructure from the point of view that it is interfacing and connected to the public network. We created custom CIDs that were used for the experiment. That was done for a reason, and the reason was that we wanted the content to be, in a sense, unpopular. We didn't want others to be requesting that, because that then would we wouldn't have the native picture of what is happening. Of course, we can get CIDs requested from the network and play around with those. We might see, the only thing that we're going to see is faster performance. You know, if there is a popular content, then the provider record and the content itself might be in more peers, and therefore we're going to get our answer faster. So we wanted to kind of see the worst case scenario of what is happening. But totally, yes, we can do that.
Yeah, is there a way for, if people are running this type of infrastructure, to use your system to also see these metrics on their own?
Yeah, absolutely. Yeah, it's open source. This the whole deployment of everything we use is open source, and I can provide the links here.
Super cool.
Totally. Yeah.
I'm curious if the scale of measurement of the measurement infrastructure could be very useful for other kinds of things. Like, for example, figuring out latencies to certain kinds of nodes. A lot of the people in the Falcon ecosystem are trying to get extremely low latency retrieval. And one of the things that we need to get to is persistent measurements of the retrievability of certain pieces of data with sub-second retrieval from various parts of the world.
Yeah.
And so I'm thinking if you could wave a magic wand and get whatever you wanted, what would be kind of like the scale of the measurement infrastructure? Like, if you could have like tens of thousands of nodes or hundreds of thousands of nodes probing things, like what kind of scale do you think would be like the top end of what you would want to get?
Right. So yeah, that's an interesting point, and we have had requests to go and retrieve content through gateways, through Go IPFS, through Hydra nodes and so on. And that's an experiment that we have not done. We should do. Now, regarding the scale, I don't think we would need so many nodes to be able to get base results on retrievability and retrieval latency and so on. What we are building with some other of our collaborators, which we were just discussing, is if we can get some telemetry data into a big number of nodes, like a number was flying around today, about 10% of the network, that would give us much better view of what is actually happening in a kind of day-to-day scenario. So the kind of problem there, well, there is no problem, but people will need to run this extra plugin. It's not plugin; it's going to be within a release, and sometimes people might raise privacy concerns. So we need to see how to deal with that.
I was actually just hoping you could expand on that. Sorry.
Yeah.
Because all the metrics that you presented are basically publicly measurable, right? You're able to pull all that just by crawling the network and understanding how different nodes are behaving. And then you just led into the other half of the equation, which is sort of telemetry coming from nodes, opting in to produce metrics around how the internals of a process are performing. What's your how valuable is that data to you in relation to what you've been able to gather publicly?
I think it's different nature of things that we would be able to collect, because we cannot, of course, like running this experiment, we can only go to our homes or public cloud infrastructure that we can go and deploy nodes. If there was a user base of 1,000 or 5,000 or 10,000 nodes in every home in random places across the world, obviously you'd get much more accurate results on what kind of real life looks like. So I think that would be an issue. Another issue would be that, for example, we cannot measure, say, bandwidth availability from home networks. It's very different. So being able to have a heat map of that sort of metrics, I think it would give us for like kind of relatively futuristic development of the DHT, are there nodes with a server profile where there is high bandwidth, low latency, and high uptime, and are there users that are connecting from more flaky connections and so on, and perhaps that could then influence other things that we're doing with provider records and with storing content and so on. So yes and no.
Thank you for your presentation, and sorry for my English. I was wondering about, do you have an idea of the proportion of nodes that are like personal computer? And so, for example, when people are like turning off their computer,
right,
it like stops the instance.
Yeah.
And yeah.
Yeah, the answer is basically no. It's very difficult to figure this out. What we do, other than what I presented here as, this is the percentage of nodes that run on big cloud infrastructure. So that's as close as one can get right now. There are some things on periodicity of how, here, connectivity times, and if that follows some time of day pattern where in the evening, whatever, people close their laptops and so on. But it's not possible to do that unless we have this other type of measurement where there is some software that runs into the actual machines.
Because I can imagine with a smartphone, the runtime is much more smaller.
Yeah.
So
yeah,
maybe,
yeah.
Thank you.
Thanks, Yiannis. Just two quick things. One, great things have occurred once you've actually taken measurements, and you kind of explain the importance of measuring so you can then figure out what to fix. I'm curious, how do you develop the intuition of what to actually go measure? And the second thing I wanted to quickly ask is, where could I hang out with you this evening to talk more with the team and IPFS and Lit P2P folks?
Yeah, starting from the last one, there is going to be Lit P2P sponsored dinner and drinks later on from 8 p.m. roughly on that corner of the venue there. So, I don't know, pick a sticker, and that's the identification. There is a meetup event as well, which you might have registered. That's where everyone is going to be, the Lit P2P team, ourselves, and so on. More generally, I forgot to put it here, the team that is working on that lives in the IPFS Discord in the channel #probe-lab. So you can find us there. It's a public channel, so come hang around with us. And on the first question on how do you develop the intuition, I think more generally, I am following, and I would follow something from the more general, from the more high level, and dig from there wherever you see, things that you would not expect, abnormalities or things that look awkward, are not intuitive. That's where you then go and dig a little bit deeper. So, breaking down the whole life cycle of content from publishing to getting content, you come up with this initial graph of tens of seconds or 100 seconds to provide content. So immediately that's a bell there that, something is not right. We should go and look a little bit closer what's going on.
Thank you so much. So now, big round of applause to Yiannis. Thank you so much.